Ladies and gentlemen, hello and welcome to today's webcast, Defending Network Availability with Detailed OSA Analytics, ZEN OSA Monitor. Before we begin, I'd like to review some housekeeping items. Today's webcast audio is streamed through your computer speakers. If you need technical assistance with the web interface or audio, please reach out to us using the chat window. The presentation is scheduled to last approximately 45 minutes, and there will be time for questions and answers at the end. You can submit questions at any time throughout the presentation using the chat window, and we'll endeavour to answer as many of them as we can. If we don't get to your question, we will follow up via email. Excuse me. The webcast is being recorded, and you'll receive an email next week with a link to download both the recording and the slides, and we encourage you to share these with your colleagues who were unable to make it today. I'd like to introduce you to the people who are presenting today and who are online to answer questions. There's Stuart Willis, who is a senior software engineer who has extensive knowledge of networks and networking monitoring tools, as does David Friedman, a senior software engineer also. We also have Dave Sinclair on the line. He's the lead developer of the team who developed ZEN OSA Monitor, and he's on hand to assist with questions as well if needed. My name is Ian Green. I have been working in the mainframe environment for most of my working life. I'm an account executive for SyncSort, and before the acquisition of WDS by SyncSort, I worked with WDS for over 5 years. You're no doubt with us because you're aware that the OSAs can be a single point of failure on your network, and as such they are mission critical. You need to know that you are doing everything possible to monitor and manage these essential devices. This presentation will focus on our unique OSA monitor, and no other company offers a dedicated OSA monitor. To do this, we're going to need to show you some other components of ZEN, namely the ZEN Permanent Real-Time IP Monitor, formerly called Implex, and ZEN Trace and Solve, which is formerly called Exigence. Now, other organizations offer information via their IP monitors, which are OSA aware, but do not monitor the hardware. We will demonstrate for you what you can see from an IP monitor perspective, and then from an OSA monitor perspective. Also, how easy it is to run an OSA intertrace and to analyze it. How alerting can preempt potential issues. How it is possible to do a soft reset of the OSAs without having to disconnect all the devices attached to it, and much more. Right, we have a lot of content to cover, so I'm going to hand over to Stuart Willis now, and we'll get started. Stuart, over to you.
Thank you, Ian. Good morning, ladies and gentlemen. It's nice to see some familiar names on the attendee list that have probably heard me speak before. Hopefully you'll find the presentation interesting and informative. Excuse me. I'll start by explaining a little bit about ZEN itself. ZEN is a single interface into the various components that make up the ZEN as a complete family suite. There is a common feel and look to all the panels, irrespective of which part of the component you're actually going to be using. I will show this a bit more as and when we get into the presentation. It's a fairly simple SMP install. All the components are installed into the same set of libraries. There's no third-party software required as far as the web serving is actually concerned. We actually use a web server internally within the ZEN component itself, and that does all the web serving, so you don't need anything like Apache or any of the other web interfaces out there. It also includes a bunch of network management tools, things like ping, traceroute and stuff like that, that comes as part of the base component itself, and there's a common code within the base that supplies the information for a number of the components. It can replace things like NetView and other network management tools for less cost, but that's a sales. We're here really for a technical overview of the ZEN OSA Monitor. As Ian said, we will actually be touching on some of the other components within the ZEN product, because there is interfaces between the various components, and the information that is displayed really depends on which components are installed on the system itself. What I'd like now to do is actually go into the live presentation. If I can share my... Hopefully you will, can all now see my ZEN desktop. Before we get into the ZEN itself, I'd like to speak a little bit about where we actually collect the data for the ZEN OSA Monitor displays. We have a number of APIs that are used by multiple elements, multiple components, that actually extract information from things like VTAM, from TCP/IP, OMVS, and other elements within the MVS operating system. So this supplies some of the information for the actual displays. We also use the EMCS console for issuing commands and receiving commands back from messages and displays back from the MVS console. The majority of the information itself comes from OSNMP and the IOB SNMP daemons that are supplied by IBM that actually interface with the hardware itself and extracts the information, the MIB information from the OSA itself. So we have a connection into these daemons to extract the MIB information, and then is actually displayed back to the displays. Unlike our IP Monitor and Exigence and ZTS Monitor, the data is actually data collected by the system itself. It's not collected via our own data capture routine. So the information is slightly historical because it's the information that has been written out by the hardware to the various MIB, the MIB entries within the firmware in the hardware. So that's really where we actually extract the information from. We have, with ZOM itself, with the OSA Monitor, you have the ability to monitor local and also remote OSAs. We'll come a bit more onto this when we come into the configuration. Typically, a hardware will have an OSA card which will have multiple ports, and those multiple ports can be shared across various LPARs and across various sysplexes. If we look at the display that we've got here, within ZEN itself, there are a bunch of panels, and the panels all have the same look and feel. Each of the panels has help information on it, and we have this concept of a desktop. If I come down to the bottom and switch it off, this is ZENs. There's multiple ZENs talking to each other and passes information. If we now go into the OSA network itself, so what we're seeing here is a schematical view of the OSAs, the ports that we're actually monitoring. Now, for demonstration purposes, what we've actually done is we have two systems, two physical data centers within the SyncSort WDS environment. One is in Westcliff Lake in America, and the other one is in East Grinstead in the UK. If we look at the top two elements that go to CHIPID 24, they're actually from LPAR Plex 1 and Plex 2. And then underneath that we have LPAR ZOS 1 and ZOS 2. Now these two systems are actually on different sides of the Atlantic. We've actually got the ZOS 1 up the top where it's got OSA UK. That is the system, the Z9 in the UK in East Grinstead, and then the other ones, the OSA Gig Chip 1 and Gig 10 OSA Gig 10.2. These two systems are actually on the EC12 within the in America. Now, typically you wouldn't run this as this kind of configuration, because we're looking at OSA at the OSA monitoring at the hardware level, as opposed to actually at the IP or the Z OS environment. So purely for demonstration purposes and the way that we can actually see that the OSA Mon can monitor multiple OSAs, I've actually linked the two systems together. Typically you would have one plex, a sysplex being monitored, or systems that run within the same physical hardware. Now, if we go into the OSA Monitor configuration, if I move that down, what we've got here, when OSA Monitor comes up, it dynamically finds out, it does a discovery of the OSAs that are sitting on this particular system. Now, in this case, we're running on the ZOS2 system in Westcliff, in the American system. So those would be what we would call local OSAs. So we can see at the very top, we've got two OSAs which have an address of 192.168.61.25 and 125. So they are local OSAs to this particular ZEN environment. The ones below it, we've got here, we can see here by the panel, these are actually remote OSAs. So what's happening is there is a TCP/IP connectivity between the systems in America and also systems in the UK. You'll see the OSA UK actually has 10.5.1.111 and 112. So it's a completely different networking structure, different subnets. So this is actually, this ZOM on this system is actually configured to go out to those systems and speak to the daemons, the IOB SNMP and the OSNMP daemons that run on that ZOS system in the United Kingdom. Now, the only configuration that really needs doing is to specify the OSA name within this configuration, because we have no way of knowing which OSA, which port connects to which OSA, then it's very difficult for us to actually then amalgamate that information into the displays. So, excuse me. So in here we can actually put in the configuration. Now, the only real security within the OSNMP, the MIB, is a community name. So we have the ability within this configuration to actually specify a community name for that particular daemon. So if you do actually have daemons that have non-standard, public is a standard community name, then we can actually fill that in within this panel, and we can give you, we can then connect to. Over on the right hand side we see that we've got green SNMP, so that is actually telling me that these OSAs are actually in connection with this particular ZEN OSA Monitor system. Up the top we have a little help window, and all the panels have context sensitive help information. So any of the panels that you want within ZEN, not the ZOM but the IP Monitor and all the other components within the system, actually have help on them. We can see here green if it goes red or if it goes grey. So all the information that is required on the panels is actually available from within the panels themselves. So you don't need to go off and look at manuals. All the information is within there. So that's actually the configuration of the OSA Monitor. There is also a bunch of other settings that we actually require for ZOM to work. Real-time displays, as I said at the beginning, we actually go out to the OSNMPD daemons and things to extract the information. Now that is done on a interval. We can see here that this is actually an interval. What you can do is you can change that, and you can also change the real-time displays to be displayed in real time. There is an overhead on this on the system in that we will be doing more work and going out for the information. But that is an option you can have. And there's a SMF. We write out SMF records that can be used to be imported into our own ZEN reporting system, which I can show you later. So we can write out SMF records, or if you've got your own SMF reporting products, we do provide the data descriptors for the SMF records. And there's other information as far as the configuration, the Palm-lib members within this panel. So these values are changed dynamically as we go through. You can change them dynamically. Come back in OSA administration. Rules and alerts. As indicated at the beginning at the start, OSA Monitor has the ability to issue alerts on a number of different statuses. I will actually be covering the alerts themselves a little bit later within my presentation. But in this panel, what we do is we can actually go in and set up the specific values for these particular triggers. So we've got here, we can have high and low throughputs. We have also come down a number of errors encountered. The MIB itself returns a number of values, and what ZOM does is it actually monitors those values and sees if there's any changes within the values. This does require an element of understanding of these various values by the customer to actually know what that they actually want to look. We've got OSA error counters, errors within the system, and there's different types of errors. Typically, a lot of these are switched off, but we do have something at the bottom, at the top of the display that is actually monitored. So these alerts will be monitored. ZOM status change is triggered at 4. So if the value changes above 4, we would then actually go off and issue an alert for that. We've also got the ability to stop alerting, apply, save, reset, and close within here. So it's a way of controlling the alerting and the rules. A lot of these panels are actually controlled via RACF. So the ZEN environment itself is actually controlled by RACF classes, and that's set up as part of this, the system installation and setup. So you can prevent people going in here and switching on alerting and switching off alerting. So you can have different authorities, either be read or all the way through to update and change. So those are the rules in alerting. So I will come on to the actual alerting a little bit later in the presentation. We come in here and we look at history capture. As I said, we do actually keep historical information within the system itself, and I will be showing you some of the historical displays once we get down into the nitty-gritty of the display. So what we've got here is the history capture is active, the interval is 5 minutes, starting date, stop date, the file capacity. A lot of people say, how big should the files be? Well, it really depends on the number of alerts and the number of OSAs that you've monitored. The SMF status, at the moment, we're not recording SMF on this particular system, but we're seeing that the SMF record time and the interval, and if we were collecting information, then we would actually have a figure in here of the number of SMF records being written out to the system. We also have soft reset. That actually resets a bunch of values within the OSA monitoring environment. I will come to that when we actually go into those panels, but you can dynamically do a soft reset of the values. So if you was to make some changes to a system, typically you'd want a stake in the ground as to what the system were before I made my changes. So what you would do is you would make the changes, do the soft reset, and then you would actually see whether those changes have actually improved or or cause more problems within the changes that you've made. So that really gives you the administrative and how you set up ZOM. This panel here is actually showing us the schematic of the OSAs on this particular system that we're monitoring. And as you can see, as I move my cursor over the various panels, we get various tooltips pop up over here. And we know these top ones are actually remote OSAs. So if I was to click on, I missed it. If I was to click on TCP here, I'd actually get this panel up that says no data available. Because this is actually a remote OSA, we don't have the information available on this particular system to display that IP information. But if I come down to one of the systems on ZOS2, then this information is actually here and displayable. At this point in time, we're actually looking at data that is being extracted and displayed by the ZEN IP Monitor. So if you had the ZEN IP Monitor up and running, you would get this panel. If you don't have the IP Monitor running, then you would get the no data as we would do in the remote display. I'd just like to spend a little bit of time talking about the difference between an IP monitor and the OSA monitor itself. Typically, an IP monitor would monitor a OSA within a single stack. So if you had multiple stacks within the system, the packet throughput and the connections would be specific and unique to that particular IP stack. I'm aware of a number of our European customers that actually run multiple stacks, some for gateway, they do routing through their stacks and things like that. So this information is purely looking at the packets and the throughput that relate to that particular IP stack. But what we're looking here, and this is the information that we're actually seeing, so this information is coming from the ZEN IP Monitor. But if we actually start looking at the OSA itself, then what we see is that the information, apologies. This information is the information that we're actually seeing as the OSA at the hardware level. So we're actually getting the information that is being collected is the collection of the packets that are going through the physical hardware at that point, as opposed to the IP stack itself. So the values and the figures and the error rates are shown at the hardware level, not at the IP level. So that is the difference between an IP monitor and the OSA monitor, because the OSA monitor is more analogous to the actual hardware itself as opposed to the particular stack. I will look at some more of these displays as we go through. So all this information you can get to from either this main display, and any of these panels we can click on, we can see it. But what we've got is up across the top, we've got what we call the menu bar. And in this particular system, we click on OSA, and then we get a bunch of drop-down panels. So if I now come into the OSA display, and we want to look at a particular OSA on this system. So this is a local connection, or this is the local OSA on this particular ZEN OSA ZOS2. We've got a number of graphs on here. This is on the American system, but in America at the moment it's something like about 4 o'clock, 5 o'clock in the morning, or 5:30. So consequently the packet rates are somewhat less than what we'd like to see. So the actual graphs and the figures are really quite low. We're seeing sort of utility in throughput is really quite low at this point in time. But hopefully you'll get sufficient, there'll be sufficient information to get an idea of what we're actually seeing. So the panel itself is made up of a number of sections. What we've got here is interfaces using this particular gig point interface OSA 1, and we can see here that we've actually got two systems. We've got ZOS 1 and ZOS 2. So this particular OSA is being used by different ZOS LPARs within this system. We can see the sysplex name, the IP address, and other information. That information is actually extracted from the APIs when the auto discovery started. When you do a remote OSA, that information has to be entered in manually because we've got no auto discovery on that system. So if we go around some of the information, if I click on CHIPID, what we get here is actually the channel path ID that is part of the actual information itself within the OSA, the IOCP itself. In here we get a bunch of values: current value, last value, and as I said here, we've got this reference value. At the moment, this is actually blank in this system. So if I come into OSA configuration, into here, OSA history category. If I do a soft reset here, so that's now done a soft reset. So if I do a close and a refresh, what we can see here is that that system has now done a soft reset. So all these values have been set within the reference. So we've come down here and we've got a number of values down the bottom. But as I said, unfortunately, there's not a lot going on. We've got there's some values here. So if you were to do a soft reset here and then go off and make some changes to your system, to the configuration, to the environment, then come back and we would see a refresh, and then we'd see current value and last value. So you'd have the ability to actually see the information that has changed since you did the soft reset. And there is another panel that actually gives you the information and the time that the soft reset was done on this particular channel path ID. If we go into help, there's a bunch of information on the different types of values within here. We can see the type of OSA itself. It's an OSA Express 5, an Ethernet card, and then there's some other processing code levels. So this is all extracted back from the MIB itself. Again, some of this may not mean much to people and may not be relevant, but if IBM phone up and say what license code and stuff you're working, you don't have to go to the HMC to actually extract that information. You've got that very close to hand. Coming across, if we go in and actually look at the gigabit port itself, this is the information very much like we had for the channel path ID, and in here we've got the reference value, last value, current value. Because I did the reset on this particular system, then these values are actually already pre-filled in. So what we're seeing here is the reference value for the total transmitted packets, the total number of received packets, and then as we work our way down, there's lots of information in here giving us the maximum broadcasts, the packets received and things. So again, it's a way of having a stake in the ground if you're looking at making changes to the system, that you can actually come in and look at these particular panels. We come across the top, packet sizes. There's a little graph that we actually show that we can extract the information. This panel actually only works on certain OSAs, OSA 5s and etc. It's only with the later types of OSAs. So what we've got here is this actually shows you the breakdown of the particular packets on this particular port on there. And then we've got some other panels for reference and lifetime. These probably be all much the same, because there's a lot of these panels that once they get set, the information is kind of the same. But what we're seeing here is the send and receive packets and the received packets within this graph on this system. And if you toggle, like with all the graphs within the ZEN environment, the ZEN display environment, if you hold the cursor over, you can actually get the real figures across the top, and that's just because we're using the same method of graphing within the ZEN environment itself. Then that's you can see the actual figures. We've also got up here, there's a little printer button, which is a handy feature within ZEN itself. Typically, if you want to take a screenshot of that, you'd have to go in and screenshot it in Paint. Whereas if I click on the little printer button, then that will actually take a copy of that and send it off to any printer that's attached to this particular PC. Again, that's another feature within ZEN itself, not necessarily within the actual OSA monitor itself. We can see here port state is active and the SNMP state is active, and SNMP is responding. There's a tooltip. If it wasn't responding, this would go into an amber. We have a traffic light system. Red, it's down. Amber, there's a potential problem. Or green, it's happy, and we're getting information back from the daemon itself. If I move down the panel, we've come across here, we've got a little box over here, that little grey box, and typically grey boxes within ZEN open up other panels. What we can do in here is we can run down these the various displays, so we can actually go in and look at the MIB display itself. So this is the information that we're actually building the panels from. If you know that there's various products out there like Resolver and stuff like that, that will actually go off and display MIBs. The ZEN IP Monitor itself will actually display these MIBs as well, and you can do a MIB walk through the actual MIBs itself. So what we're seeing here is these are the figures that we are actually using to build the panels and the displays from. If I come in here and click on it again, if I do it, that's in the detail view, and what we can do here is actually look at it within the ASCII. Typically that's not particularly relevant for the displays, but certainly if we've got problems that we need to resolve within the product itself, we ask you to send a display of this, and so we can actually see the information that's coming back from within the MIB itself. Start OSA intertraces, we'll come on to that later. We can issue VTAM commands directly from within the OSA monitor itself. So if you wanted to, without having to go off to the console, if you wanted to do a DNet TRLE information, so we can actually see the VTAM status of this particular OSA straight from this panel, so you don't need to go off to the operator console, log on to TSO and issue the command. We can issue the command dynamically directly from within this panel. So in here we can see the various statuses of this particular VTAM, the VTAM TRLE information in this system. Coming to OSA information is, again, these are commands that we can issue dynamically through the operator interface within the system itself. So we can actually display the information. Again, if you're looking for possible problems within the OSA, we can see here that this active speed on this one is actually 100 megabits per second, and it's running in full duplex, and this is actually a copper as opposed to a fiber connection. So all this information can be got by typing the command in through the MVS console, but we have this to be able to display these automatically from within the panels itself. We come down, there's a couple more. DevStatNet, netstat device command. Again, this is providing more information through just issuing the ONet stat. It issues the ONet stat because we have interfaces into the OMVS environment within ZEN. It's not just the standard netstat. So we've got all this information coming back. So if you are looking for potential problems or issues, then you can get this information directly from within these panels. VCR details that there's no dynamic Viper configuration routing on this particular system because we don't run, but if there was, then we'd actually be able to show any dynamic routing, Viper dynamic routing within the system. So we've got the same information for the various OSAs on the system. OSA information itself actually gives us more information on the OSA, But what we've got here is a bunch of information as far as the interface addresses, the stack name TCP/IP that we're connected to the OSA, a bunch of hardware information, including things like MAC addresses and the burnt-in MAC addresses. Again, we are talking more in the hardware environment because this is what OSA Monitor is doing. It's monitoring more of the hardware. So we see max speed. There's no MTUs in here. We've got other handy things like we can actually see the read-write devices. Typically, you'd get 4 devices for an OSA, a read, a write, a data, and also the trace device. We can see here at the moment this is the physical CU of this, right, and it's currently sitting in reset. So we wouldn't actually have, if we were to have a OSA trace running, that would actually be sitting as active. Number of OS and MP requests that have been made. Any failures? Luckily on here they're all 0, and the average time for response times. Again, this is more information for ZOM itself and the way that ZOM is actually handling that information. But we do actually have this information to hand, so it was worthwhile actually displaying it within the panels themselves. Moving across OSA information, again we've already been down there when we're looking at the OSA system 2. We can actually go in and see a bit more information within the actual the performance table itself. So we can see the CSS IDs within here, processor utility, out bytes and in bytes per second. Then this information is the information that will be displayed within the graphical information on the underlying panel. Chipid, so again we can see the chipids. Now we can come across over to here. I was saying that we actually have historical information. Sorry, I did that a bit quick. I'll slow down a bit. We've got here packets in, packets out, and then the I/O rates. Now this is using the historical data that we've actually collected on this particular system. And as you can see, we go back 1 hour, 3 hours, 1 day, 1 week. If we go back 4 weeks and issue a refresh, it comes back. So what we can now see is this particular the OSA performance on this particular system for over the last 4 weeks for this particular OSA. So we're looking at OSA 1 on ZOS 2. So we can actually see the peaks and troughs of this particular OSA as far as the performance. So we see interface, input and output. This could be handy if you've got something like a Sysplex distributor where you're sending information in via one system and the information comes out via another interface. So if you were to compare the input and the output, so what we're getting here is there's the number of inputs and number of output on this particular system. But what we can do is then go across to OSA, to another OSA and issue refresh. And then what we should do is, so what we've now done is from within this one panel, we're actually looking at the input, the historical data across the 2 OSAs. This is one's from ZOS 1 and the other one's from ZOS 2. So I'll come back. If I try to go across to Plex 2 and do a refresh, what we can see here is this is the one in the UK over the last 4 weeks, and very little actually happens on that system. So that's why we use the system in the States, because there's more information in it. So these I/O rates are within here. Coming across the alert status, we'll come on to that when we look at alerts, and then we come down here. Then we've got some more information. ZEN OSA path. So the figures we would be seeing down here is the path using this particular channel IP, and we would get the graphical information here. Processor utilization in out, kilobytes per second over the last 3 minutes, the last hour. So you can get a view of the information of this particular port on the system. So it gives you an overview of that panel. if I now come down to there's a bunch of other channel ports. So what we're looking now is the information via the channel port view. So what we can see here is this information via looking at it from within the channel ports themselves. So we can see here packets in, packets out, byte rates, and then all this information on the various ports on the OSA UK. So it's another way of looking at the information, but from a slightly different angle on this. So we're looking at this as OSA channels and the port information. Come down, interface view. So again, we have the same sort of information, but we're looking at this through a particular interface. So we can see here that this is OSA 1, this is link OSA 40, and then OSA T2. So the figures in here are looking at it from within an interface. So the underlying displays and the underlying information that we get would still be the same, and it would point us through to the same panels, but you're looking at it from a different information. If I was to come down here and click on here, we'd actually see this particular display. We've only got two options. We've got MIB view and dump view. Whereas if we come up to these other panels, we've got a lot more information because these are the remote OSAs. So the ZOM itself doesn't have the ability to go off and issue commands, things like TRLE information and the ONET stat. So the information you actually get is really dependent on the system or the OSA that you're looking at and where that is within the environment. So this one is a remote information. So all the information we're getting back from this particular display is purely from the OSNMP daemon information. It's not from within the internal APIs and the console messages. Local VTAM view. As I said, these are local VTAMs. So what we can see here is this is information that comes back from the TRLE and the VTAM interface, which we've looked at a lot of these already, but this shows us the actual system that we're looking at, and these are the local OSAs. So we can see the current status, the stack that it's connected to. This one, we only run a single stack on this system, but if you was to have multiple stacks, then we would actually see the stack that's the actual active status, and then if there was any congestion within the actual VTAM configuration itself. So if I hold the mouse over the particular icon, and then we get a tooltip that pops up, and then it gives you the information and maximum queue depths under there. And if we click on this little display here, there are no queue depths on this particular system. If we go back and do a refresh over the last 4 weeks, so we've got no excessive queue depths. If you were starting to get queue depths, you would actually get a graph starting to appear on here, and that possibly would indicate an issue of a problem on this particular OSA. But over here, these are all green, so everything is fine on those particular OSAs. OSA health check. As I said, OSA's ZOM itself goes around and does checks. In this particular instance, we've actually got no errors currently outstanding. Where we've got an error would be that the MIB would actually change the information. There would be an increase or a decrease in the number of the values within the MIB detail. So we see here, if we go off and do a full health check, again, there's nothing within the system. Typically, you wouldn't see anything in here unless you was experiencing problems within the system itself. The OSA alerts. As I said, OSA has the ability to, or ZEN has the ability to issue alerts. And in here, what we've got is there's just one alert on this particular system, and we click on that, and it gives you the information here. Operator stop is not enabled. These are alerts that were artificially generated for the purpose of review. But if we go into ZEN and then actually look at the alerting itself, now this is getting more into the functionality of ZEN and the way that the ZEN handles alerts, but it's the same. So what we've got here is a bunch of ZEN OSA alerts, OSA not responding. So if we take this as an alert that comes out from the system, now OSA not responding, that could be that the OSA has gone inactive, or that the daemon has stopped working. Because we rely on the daemon to be there to actually pass us the information, it could be that the daemon has gone inactive and has stopped working. So a bit of investigation would need to be done, whether it's that or whether the OSA itself has physically. But we've got a number of ways of reporting those alerts. If I come down here, we can write it to sysout, archive, to console, out to NetView, SNMP traps. We can send an email out to a particular one. A new function that has not been announced yet, but ZEN IronStream, the ability to issue the alerts out to a Splunk server is being developed. Again, this is a development system, so it is active here, but it's not been officially announced. What we've got here is the alert description, the alert class, the category, and the alert severity. These are all severity zeros. If I come to the alerts and look at the alert summary, we've got here, this system is running multiple components, and we've got a bunch of different severities. So you can set severity as being 1. To me, if an OSA is not responding, then that OSA is a high severity. So to me, as an operations person, I would set that as a severity 1, because there is a possibility the OSA has gone down. So people are going to start phoning your support desks and saying, I can't get in. So that would be a high severity. Alert frequency, that just determines how often the alert comes out. Default is 0, so every alert would come out, but you could set it to 10, so you'd only get every 10th alert out. Mail recipients, so we can send out to an email, providing this ZOS environment has access to your email server. Then that's how we would then send the alerts out to a particular alert address. Typically, that would go to a group within the email environment as to a specific person. Commands. ZEN has a full-functioned exec and automation system where we can issue commands, we can run rexes, and we can do a whole bunch of other good bits and pieces within the command. So in the event that this OSA not responding, what we could do is issue a command, okay, I will restart my OSNMP daemon on this particular system, just to see if that was the problem. So you'd run a command which would run a ZEN rex that would go off. It would issue a stop for the OSNMP and the IOBSNMP and restart it. And then hopefully, if that's all the cases, then you would know that that this has happened and a restart has resolved the problem. If the alert then came out again, you could then set some counters within the rex itself, which would be user-defined and user-configured. We could then go off and have a look at the actual the OSA itself and see whether this is a hardware problem. So this is how we would issue alerts out, and the same would be for all the components. So there's a single alert system within ZEN itself. If I just close these down. So that's the alert in itself. We also just want to touch on OSA Entertrace. There's within the ZTS, Zen Trace and Solve, we can take IP traces and SNA traces itself using our own bespoke data capture. We've got no way of doing that within the ZEN OSA tracing, so we actually have to use the IBM C trace to actually take the trace. And those that have ever tried to use C trace can are aware there is a bunch of commands that you have to get, and you have to get them in the right order, and then you have to have started writer tasks. So what we've got here is the ability within ZEN OSA to actually go off and define the criteria for the trace within these panels. So what we've got here is these are the traces the particular ports that we want to trace. We can then select an IP trace, but we can also go in and select the various protocols. This one's set up for TCP. You could do UDP and also ICMP and ICMP v6. All the ZEN components are all IP6 tolerant. Some of them are actually, like the IP Monitor, you can monitor IPv6, but in this case we're just doing IPv4. So in here we've got v4, v6, ARP, and an SLA. So likewise with the MAC address, you can filter and select on a whole bunch of things. So I've got this set up. So what I'll now do is actually start the trace. Now what this is going to do, it's going to go off, and in the background it will actually start. Oops, sorry, I've minimized the wrong one. This has actually gone off and started a trace on the ZEN OSA environment. And if I view the log for this particular trace, what we can see here is the actual command that ZEN OSA trace has actually gone off. So in here we can see the start of the trace, right? The writer task. We can then see these are the MVS commands that actually get generated by the OSA Mon itself. These are built depending on what filters are selected within the actual panel itself. So this is the information that comes back from the MVS console. So we apply the filters, we then start the writer task itself, we then go off and activate the trace, and last thing is the vary TCP enter trace. So this is actually starting the trace itself. So that's the actual trace running. If I come over back to this initial refresh, what we'll see, hopefully you can see the data bytes are actually going up. So if I click on refresh, so we're actually collecting data at this point in time. If I now go off and end this trace, then what that will do is it will actually go off and issue the command under the cover to actually do the termination of that particular trace. And eventually it's now come back and it says the trace has actually been stopped and is actually stopped. So that trace is then out on the system itself. And what we can then do is we can actually import that trace into the exigent ZRP system itself. So if I come into the IP ZEN trace and solve, and what I want to do is actually import a trace itself. So if I enter the data set, this is the data set from the started task that was actually sent up and has been running for this particular trace. If I then put in trace, if I do an import and let that go, hopefully that will import file, refresh. Don't you just love live demos? I was a bit too quick. If I now look at this is the imported trace that came out, I can now go off and actually with the trace and solve product itself, which is this is over and above the actual. This is a separate component within the ZEN environment, but it just shows you that there is an interface, or there is a way of taking this ZEN OSA trace. You could go off into IPCS and monitor it and actually display it as you would do a standard C trace, but we have the ability to import an OSA enter trace into our trace and solve product. And so what we can then go off and actually go in and have a look at the actual trace itself and step forward next. I won't go too much into this, but just it's to show you that ZEN has a bunch of components, and all the components really link together to make a single system where you can do everything from within one panel or one interface into the system without going off and having a look at a whole bunch of different screens, logging onto TSO, into ISPF and things like that. So that's the actual OSA intertrace itself. I did say we do collect SMF records, and this goes into our ZEN reporting product, of which there is a bunch of canned configurations. Here we can actually see this is some information taken some while ago on our UK system, and what we can see here is the SysID, timestamp, and this gives us the IP addresses, and over here we've got some information as far as packets in, packets out. Sadly, a lot of these are just zero figures because we don't really drive our OSAs at a high rate, but it does give you the ability within the reporting and the SMF environment to go off and to produce trend analysis and things like that. Should you be looking at upgrading your OSAs or upgrading your hardware, then this will actually give you information over a historical base. This goes back to July 2013, so it's fairly old data on this system, but we get the various queue depths, the I/O, so you have a way of actually taking this and then producing reports from within the ZEN reporting part of the ZEN family of products to actually give you that information. This really concludes my part of the presentation. Hopefully you haven't all kind of dropped off to sleep, and there is quite a lot within the system itself, and without knowing our configuration, typically it would be more meaningful on a customer's own configuration because they'd understand their IP addressing structures and their port sort of thing. So I will now hand back to Jessica for any questions, and I'd just like to thank you for your time.
Wonderful, thank you very much. So we have a few questions that came in throughout the course of the webcast, and I will just read them off. The first question, do I need a copy of an OSA monitor on all of my systems?
Right. Technically, no. As I showed within the system, we actually had ZEN and OSA Monitor purely running on the ZOS2 system on in America. But the system, the remote OSAs that I was looking at within the UK system, the information that we were getting, then that was a partial information. So typically you can run it from within one system and you get all the alerting, but the other information that you receive from the system as far as the VTAM, what you would have to do is you'd have to log on to the ZEN on that particular system to get that information. So it's a two-part answer. You don't need to, but to get full functionality of all the all the display components, then you would need it on both systems.
Great. And we have a question that just came in. How does it differ from NetMaster?
It's a slightly different animal in that NetMaster, I'm not a NetMaster expert, but NetMaster really only monitors the information at the IP level. As I said in my presentation, that's only monitoring the packets that flow through the stack itself. It doesn't actually monitor the OSA at the hardware level. So in this instance, we're comparing slightly different products because NetMaster is an IP monitor, which is comparable to our ZEN IP monitor, whereas the OSA monitor is more an OSA monitoring the hardware as opposed to the IP traffic.
Yes, Stuart, in addition to that, there's, I mean, all the components that are within NetMaster are available within ZEN, the difference being that ZEN runs in a permanent real-time mode. So it's constantly inspecting every packet that traverses the stack. without creating an overhead on the system. So there are subtle differences in the way in which the products work. One is permanent real time, one is not. I hope that answers the question for Sumesh.
And we have a question. Is an OSA monitor secure?
Sorry?
Is an OSA monitor secure?
So say that again, please.
Is an OSA monitor secure?
Right.
Oh, sorry, OSA monitor secure. It is in that the actual daemons themselves have a community name on them, so they're actually the community name would prevent anybody getting access to the MIB information. Not that the MIB information would really give anybody any information. The packets are UDP packets, and you can't actually secure a UDP packet. So it's secure as far as the extraction of the information itself, but the packets, because they're UDP, then they do actually flow in the clear. But unless you have an in-depth knowledge of the way of the MIBs and the way that they actually return the data, then it's probably a lot of gobbledygook to some people.
Thank you. And we have, does an OSA monitor handle multiple stacks in multiple LPARs?
Yes, it can do. The only thing you would have to do is you'd have to configure the OSNMP and the IOB SNMP to actually be associated to that stack. So there is a bit more configuration on the MVS side, but the OSA monitor itself will actually pick up the information because it's the OSNMPD and the IOB SNMP supplying the information. That has to be configured to receive the information from the multiple OSAs and the multiple stacks. But OSA monitor itself doesn't actually care. It's happy to work with multiple stacks.
Great. And we have what is involved in enabling the OSNMPD and IOB SNMP daemons?
The daemons. Very little actually. IBM do actually supply you with a bunch of sample procs and also some sample HFS files as part of the install. So you just need to go into the sample libraries and start and copy those into your system. So it's a relatively, if you're just doing basic monitoring, then it's a relatively easy thing to set up. It's really kind of making sure that they're started up as part of the system and to actually get them. So it's fairly simple to start them up and get them working.
And we've received, are there limitations about sharing OSAs?
When you say limitations about sharing OSAs, is that within the ZEN OS or within the ZEN OSA Monitor itself? ZEN OSA Monitor has no issues, limitations of sharing OSAs. Any limitations would be within the hardware and the configuration of the ZEN OS environment. If that's something that I see that's come in, if people like to expand slightly more on what that is, or email Ian or the presenters, then perhaps we could answer that a bit fully if I was to understand what they mean by a limitation in sharing the OSAs.
Certainly, we'll give that individual a moment to respond, and we'll take in the interim just an additional question before we wrap it up. We have, can I monitor a VM-owned OSA with an OSA monitor?
Sadly not. It is something that we've looked at, but the actual replies back from the MIB don't appear to be in any format that we're aware of. It is something that is we've kind of been looking at, and I know Dave, the lead developer on the product, we've had several goes at trying to monitor the VM OSA. For some reason, VM it kind of there's no OS and MBPD we can talk to directly. There are some OSA SF and no, excuse me, under VM, but we're a ZEN OS shop, and ZEN OS is our main focus on networking. It is something we are aware of, but at the moment we're struggling to actually get that to work.
We will take one last question, and we can then wrap up. We have, can I see long-term trends?
Yes, as I said in my as I did the last bit of my presentation, there is the ZEN reporting side of the system where you could actually take historical data and within the SMF recording, and then you could trend that over a period of time, either using third-party SMF reporting software or ZEN or the ZEN reporting component itself, so that you can actually look at long-term trending on the system based on the information that's passed back from within the MIBs.
Great, and that will conclude our question portion of the webcast. We thank you for joining us today. We will be sending out a copy of all the slides and the recording for you to share, as we mentioned, with your colleagues later next week. Is there anything else that you gentlemen, as a presenter, would like to add before closing?
No, I'd just like to thank people for their time this morning, and hopefully that's been of usefulness and you've learned something. Thank you very much.